My name's Hugh Hunt. I'm from University of Cambridge in England.
COP21, Paris, 2015.
My name's Kevin Anderson and I'm from the University of Manchester, a little bit further north than the University of Cambridge.
Two of Britain's most eminent scientists in conversation on climate.
Unlike the previous COPs, and unlike actually till very recently, I think there's a very wide acknowledge now that the science is right and that actually the skeptics are a relatively quiet voice compared with the level of agreement now amongst a very wide constituency of people engaged in climate change that the science has got it broadly right. We know what we need to do, or at least we understand the scale of the challenge. But what we're not yet prepared to think about are what that means. We have to play that out in terms of policy, in terms of our day-to-day lives. So there's still a huge disconnect between what the science is telling us and what that actually means for us in our lives and for the policymakers. And we are very positive and upbeat about understanding the science, the importance of 2 degrees centigrade and so forth, but we're still running very scared of actually recognising the implications for what that means for contemporary society. About 7 billion people on the planet is that we, yes, they're everyone. The climate scientists, the engineers, the social scientists, the politicians. There's a real cognitive dissonance. That there's a duality within us. It's not about between different groups of people, it's within the same people. That we acknowledge the science on one side, but we don't like the repercussions of what that means on the other. So that to me is this disconnect.
Can I just add to that I think that there is this view that with solar power and wind turbines and perhaps nuclear, we might be able to wean ourselves off fossil fuels. But we have to remember that electricity generation only represents 20 or 30% of global fossil fuel generation. Now, if we are going to get onto electric cars or heating and cooling our homes electrically, that is a massive infrastructural change. That just means that your home has to be rebuilt, your streets have to have new electric cables put in. The infrastructural change is enormous. Whereas if we're just thinking about creating renewable electricity, I think politicians can sell that as a victory. And in that sense, maybe we are optimistic if that 1/5 of the problem is all that we care of, but the remaining part of the problem is still there. I like the idea that we're looking at this problem through a keyhole, and what we see through the keyhole is only a small part of the problem. And what we really need to do is to open the door and have a look at the whole problem, which we hardly ever do. Don't we have the problem that we can replace fossil fuel power generation by let's dam some rivers? Well, has the Hoover Dam been a fantastic success? Well, yes and no. We've got to look at every option we've got objectively and from all sides.
In terms of the science has been very clear now. We have these carbon budgets, and the latest report from the Intergovernmental Panel on Climate Change is really helpful here. It's the first set of reports that have ever had explicitly put in place these carbon budgets. The problem with carbon budgets, they have really big policy implications, as the old framing, which was a 2050 time frame, really, we could all just rely on engineers solving the problem in 2035 and 2040 and 2050. The carbon budget approach brings it down to what do we do today and what do we do tomorrow. So the political repercussions come out of the science. And when we look at that, the big problem we have is time. So we can come up with wonderful solutions, as you're saying, all of these, we can electrify cars, we can electrify heating to a degree and cooling, we can electrify some of industry, but that will take 2-3 decades to do that, even if we have a Marshall-style plan, which is what I would suggest we need to try and make those sort of transitions. But that will mean still we'll breach our carbon dioxide budgets. And that's why it comes down to the very difficult political part of this, which is we need in the interim to reduce our energy demand. And I would argue hugely reduced energy demand in the short term to stay within the carbon budgets. It's just an outcome of the maths.
But I think there are some things when you start looking at the actual numbers. We are, as a planet, burning fossil fuels and producing about 35 billion tonnes of carbon dioxide every year. And with a population of 7 billion, well, 35 divided by 7, that's 5 tonnes on average of carbon dioxide per person. Now, if I ask every individual on this planet to handle 5 tonnes of waste, whether it be sewage or whether it be garbage from the kitchen, 5 tonnes per year, that's massive. We do not produce 5 tonnes of household waste per year. And yet somehow we're allowed to produce 5 tonnes of CO2 waste per year. Now, if we start to think about how do we manage our lifestyle to reduce our CO2 waste to, say, 1/10 of that, well, that means you have to do essentially 1/10 of what you currently do, because everything we do is written in CO2 ink. Isn't that the way it is?
I would say there's a slight, I wouldn't say disagreement, there's a nuanced difference there, I think, because actually the we is interesting in that. The averages really can be quite misleading here. If we look at the top 1% in the States, a recent report by Piketty and Chancel says that they're emitting over 300 tonnes per person for the top 1%. And I think the bottom 1% of Nigerians are about 0.15 tonnes. So there's a factor of between a few hundred and a few thousand difference between the two. If we look at the top 10% globally, who are responsible for 50% of global emissions, their emissions are 25 to 30 tonnes per person. So what we're talking about is a relatively small percentage of the population will have to make rapid and radical reductions to their energy consumption and hence their emissions in the short to medium term. The problem is they are the policymakers. But if the rest of the population are going to have lives that are worth leading, then that 10% have to make those sorts of changes. And that's why we come up with any spurious technique we possibly can to avoid the requirement of people like us, professors and the above in terms of income levels, which relate to our emissions, having to make these sorts of radical changes to how we live our lives over the next 2 decades, whilst we put this low carbon energy supply in place.
But we can be optimistic, can't we? Surely.
No, realistic, not optimistic.
No, I think we can be optimistic, because if the solution actually does rest in the hands of relatively few people, then when it really comes to the crunch, can we really make a big difference by persuading a relatively few?
Well, in some respects it makes it easier because it's only about this few, but the problem is the impacts are on the poor. And this is what makes this quite a difficult problem. What we're saying is here, rich, generally white people in the northern hemisphere are the high emitters, and poor, generally non-white, low emitters in the southern hemisphere will suffer the impacts. So there's this huge, again, another one of these massive disconnects between people like us who've got to change our lives, and actually we're changing those lives to stop the impacts on people who are not like us. They're a long way away, and we can turn them off the TV channels if we don't like what's happening in their parts of the world. So there are lots of reasons why this becomes, very sort of what looks like initially a technical and engineering problem becomes a social political problem writ large at the global level.
But you're saying we're running out of time, and I agree with you. We're running out of time. But I've been thinking a lot about whether there's things we can do to buy ourselves time. And one side of the equation says we can buy ourselves time by using less energy.
Yes, yeah.
But perhaps some of the immediate crises that are going to happen, for instance, I'm very concerned that the polar ice is melting fast, and that perhaps when that happens, consequences like methane being released from the permafrost in northern Russia and Canada. Are there ways we can perhaps slow that process down to buy us some time to get on with what we have to do? Or is that just something that's a bridge too far? We ought not to think about it.
Well, no, I'm all for trying to think about those things. My concern a lot of times is to assume that they work, and that's what we do. As soon as there's something out there that shows some optimism or some hope, however vague and tenuous it might be, we latch onto it as if it works and it exists today. And that's actually what we've done for a long time.
So carbon sequestration, of course, works, doesn't it?
It works in the laboratory. It works in very small levels. It works in the laboratory. It works at very small levels. Whether you could scale it up to start to suck up
billion
to
tons
35,
a year.
yes. And actually, the worrying, this is where you suck the carbon dioxide either out of the atmosphere or out of chimneys from power stations, and then you store this almost as liquid CO2 somewhere for the next 1,000 or plus years. To store those sorts of quantities, that is a huge challenge. And yet that is normalised in almost all of the models that are now advising policymakers. Let's just assume that it can work at very large scale.
I think it's so much assumed that there are these acronyms that trip off the tongue. There's CCS.
Yeah.
Oh, well, CCS. What the hell are these things? Carbon capture and storage. Well, we can't capture it very effectively, and we certainly don't know how to store it effectively.
No.
But somehow CCS is fine.
Yes, yeah.
Because it's so easy to say.
And even, to me actually almost worse than that, is this idea of this thing called BECCS, biomass, energy, carbon capture and storage. So we're going to, as well as growing food for 7 to 9 billion people on the planet, we're going to grow crops that we will then harvest and then burn in our power stations and capture the CO2. And as the crops grow, they suck the CO2 out of the air through photosynthesis, and as they get burned at the power station, we capture the CO2, almost liquefy it, and store it underground. There are some sort of minor concerns, like we've got a certain amount of land on the planet, we've got to feed 7 to 9 billion people. Every other sector thinks it's going to use this. The aviation sector thinks we're going to be flying our planes based on biofuel. The shipping sector thinks the same thing. The chemical industry wants to use it as a feedstock. We're going to try and feed 9 billion people. We're on a round planet. Unless we've got another planet somewhere nearby, we're not going to be able to grow this sort of level of biomass. And yet this is again assumed in all of the models that advise in governments, because every single scenario that's been discussed that I have heard so far at this event in Paris has assumed, without mentioning it everywhere, at any time up front, that this actually works. This technology is up and running and works. And it's very speculative at best.
Well, one genie we have to pull out of the bottle is to get CO2 out of the atmosphere. We've put in the last 250 years getting on to a trillion tons of CO2. It's a big number. What does this number mean? It's so big. Like, how many grains of sand are there on a beach? It's just uncountable. But it is a big number. We've got to get it out again. Over the next century or two, it's naturally going to make its way into the oceans, and the oceans are going to become acidic. And from what we know about acidic oceans, shellfish can't make their shells. The delicate ecology of the oceans is in an extremely precarious position. So that's one genie we've got to pull out of the bag.
There are two genies here, if you like. I think one is much more realistic genie than the other one. If you're going to rub them a lamp, I think one's more likely than the other one. The first one is both are hugely challenging, but the first one, the social challenge of us actually reducing our energy consumption whilst we put in place this low carbon energy supply. Now, we have done that before. Unfortunately, they've occurred at times of things like wars. So we haven't got a war metaphor. People don't think of climate change like we do think of a war. I mean, if you think of the UK, we had 22 miles of channel and we could see the enemy the other side. We don't see climate change like that. But that's somehow the level of the scale of the urgency has to be one that is reflected by that sort of metaphor, which is hugely challenging but doable. The other genie is this highly risky approach of assuming that some technology in the future will suck the CO2 out of the air. And also in the interim, we keep our fingers crossed that these feedbacks that you were talking about before, this idea of the permafrost melting and releasing methane into the atmosphere, that these feedbacks actually won't start putting lots of other greenhouse gases into the atmosphere, and then what we do is almost irrelevant. So there are two genies there. One, actually, we have some example of actually realising it at times when things are very challenging for us, but we have done it. And the other one is this technology, Dr. Strangelove technology in 2050 or beyond, and our fingers crossed in the interim that we're not going to get these sets of feedback. So they're those two genies.
Don't you think, though, that the fixing of the ozone layer by getting rid of CFCs has kind of given people this false sense that, oh, look, we solved the ozone layer problem by replacing CFCs in our refrigerators, so we can solve this problem. And the scale of the problems are completely different. And there was a neat engineering solution to the CFC problem. What is the neat engineering solution for the CO2 problem?
This is a huge issue that we think we have these historical precedents like the ozone issue, like acid rain. I mean, the ozone issue was basically solved by bolting a hydrogen molecule onto the same chemical they were using before and selling it from the same company. And they
made money from it.
And they made money from it. And the acid rain problem, was basically solved by losing low sulfur coal. And that was pretty much how we managed to deal with it in the end, or making a shift to gas to a degree. And we think now we can do the same thing with carbon. The problem with carbon, it's in the dyes in my shirt, it's in the ship that brought my shirt here. It's how we travel to this event. It keeps the lights on, it's keeping your computer running. Carbon is completely pervasive. It's in every single facet of our daily lives. That's not the case for CFCs. It wasn't the case for the issues that fed into acid rain. So we have no historical precedent of ever being able to remove or change society in a way we're having to change it in relation to removing carbon out of it within, say, 2 to 3 decades.
So why is the mood here quite optimistic? Because to me it seems that we may well have passed some tipping points. We'll find out in the next few decades. I mean, I've been a scout leader for a while, and our motto is be prepared. And I feel as if We're not prepared, and yet it's kind of like we're hiking and we've still got another 10 miles to go before our campsite. It's getting dark. Do you think we ought to pitch up our tents? And we say, oh, we didn't bring tents.
Yeah.
I mean,
we're certainly not prepared for the sorts of temperatures we're heading towards and the impacts that we're not prepared for that at all. But again, part of the optimism comes from basically rich people in the Northern Hemisphere think that we can buy our way out of this. We see what the Dutch do. The Dutch live below sea level. Now, they say, well, we're about to do that. You're not going to do that on the coastal strip of Bangladesh where 30 million people live and it gets hit by typhoons. So the people in the Northern Hemisphere think somehow we have the wherewithal to deal with a sort of 2-3 degrees C temperature rise. But the poor people around the world simply won't. And you hear a lot of people use this language. We're able to muddle through. What that means is we'll muddle through because we're rich enough to be able to do it, and the poor will die. That's what we mean by that. I mean, there are some very concerning, the language we use, if you really sort of peel away those sort of layers and look underneath it, what we're saying is fairly savage about other parts of the world, which I think actually is quite a sad reflection on us as a species, that we've not been able to look at this issue, which is probably one of the first fully globalised issues we've had to try to address, and we look like we're failing at it we're failing at it partly because of a lack of humanity.
well, this is the modern version of let them eat cake. That we seem to be accepting of the fact that our lifestyle will not change very much.
No.
But somehow we have to put in a legal framework, a political framework, a governance framework to solve the problem without affecting our lifestyles.
Yes. And we're even buying our consciousness. And we've got this discussion that will be going on in COP, this loss and damage. $100 billion. That's less than the 15th of the UK economy that we're going to hand out every year to the poor parts of the world to deal with the impacts of climate change that we in the rich part of the world primarily have caused. And they're still arguing about $100 billion. That's probably a few years' salaries for people in the Premier Division of football. So, and that's what we're looking to hand out to the poorer parts of the world. At the same time, the IMF recently pointed out we have the subsidy to fossil fuels for this year. The subsidy to fossil fuels will be $5.3 trillion. 5.3 trillion. That's more than global spending on health. That's the subsidy to fossil fuels, not to renewables, to fossil fuels. And we're arguing about whether we should be able to find $100 billion to hand to the poor countries to deal with the climate change that we've caused. I mean, and we're using that. We don't care about the poor, but it helps us salve our conscience. We've given a few pence.
We have a disconnect as well that even the concept of a subsidy for fossil fuels, how do we start to count the cost of the damage caused by fossil fuels and attribute that cost directly to fossil fuels? Well, we need an amazing crystal ball to be able to see what the damage will be. But
that's partly the IMF. I should point out the IMF estimate does include some of those damage functions. Sort of local health issues, particularly, have played out there. I mean, they've only just looked at the number of deaths and so forth and worked out a cost per death. But what it does point out, though, is that the subsidy to fossil fuels is enormous, and therefore, when we talk about the renewables, we should not worry about the cost of renewables because it's always cheaper than the cost of fossil fuels. But because we've got a peculiar way of looking at this thing called economics, I prefer to call it astrology. But because we have that approach, we therefore say that this expensive fossil fuel is somehow cheaper than the cheaper renewables. So we have a funny way we've twisted the whole thing round. Society has been subsumed in economics, as Polanyi said many years ago. Economics should be there to serve society, but in the end now what we have is society is there to serve economics.
Isn't it interesting that there are some wonderful technologies coming forward? Solar photovoltaics, producing electricity from the sun has advanced enormously. Wind turbine technology has advanced enormously. And yet when it comes to our cars, the petrol spark ignition engine was invented more
1896, I think, wasn't it, by Rudolf Diesel and others, yeah.
Why can't we just get out of our petrol cars and into electric cars? And you sense that there are vested interests that really want us to carry on the way we are.
I mean, there certainly are vested interests, but I think we're all party to that as well. We're all reluctant to have some of these levels of change. I mean, I do think it's interesting people say, oh, well, look, we've got laptops and mobile phones. Look how quickly they've come on the scene. But what are they powered by? They're powered by the 1896 Rudolf Diesel engine, which provides our cars, the 1936 Whittle jet engine that flies us to conferences like this, and the 1897 Parsons turbine, which runs most of our power stations. So this modern society we live in is all powered by technologies that, until very recently, primarily came from before the 1940s. So though it looks a high-tech world, actually we've locked in infrastructures that have been evolving over, well over 100 years now.
And we really ought to be far more flexible, and well, inflexibility is our middle name.
Yes, I mean, we always have this idea we don't want to embrace change, which is a strange thing you hear, because of course we go through huge levels of change.
How many mobile phones or cell phones have you had in the last 10 years?
Oh, I haven't got, no, about 3 or 4 probably in the last 10 years.
And that's change. And that's a small number for most people.
Yeah.
I think it's really unhelpful to say we have been geoengineering for the last 250 years, because that kind of says, oh, and therefore it's okay to do geoengineering in another way. Because I think that isn't helpful. I think we have to accept the fact that if we are now going to enter into modifying the climate in some way, actively and intentionally, that's very different from what we've crept into unintentionally.
We've known for a quarter of a century now. The first IPCC report came out in 1990, and the emissions this year will be 60% higher than they were in 1990. So we've pretended to care about climate change for a quarter of a century now. In the last millennia, the emissions have been about almost 2.5% higher growth than they were during the 1990s. Which would just make this point about what you're calling geoengineering, but some people prefer to call it negative emission technologies. That's one of the options where we suck the carbon dioxide out of the atmosphere. That's one of the geoengineering options that's available. That is already embedded in all of the scenarios that governments are using to think about what they need to do. So it is already, it's in there and it is hidden. So we look at the IPCC scenarios, virtually all of the IPCC scenarios for 2 degrees centigrade assume you can have negative emission technologies, suck the CO2 out of the air. So they don't exist. And the reason they need to be there is because without those, the rates of reductions beg fundamental questions about our political and economic framing. So what you have is that if you have a certain view that our society can only deliver a certain level of carbon reductions every year, you can't go above that. You have to suck the CO2 out of the air. If you don't suck the CO2 out of the air, then for 2 degrees temperature rise, you have to have a reduction rate that people say cannot fit with our current economic framing of society. So in their sense, economics trumps physics.
So I think that this then, in my view, says that whatever we are proposing to do really is unlikely to work. I suspect it's unlikely to work because the decision makers are being hoodwinked into thinking that there is a pathway forward that will work. I can't see it working. I don't know whether you can see it.
No, I can't see it. Well, even if it does work, it's too risky to assume that in 2050 to 2070 some technology is going to solve the problem for us. It's just too risky. So I think we have to look at actually what can we deliver today. I think it's incredibly unlikely we'll hold to 2 degrees centigrade, but it is a choice. We know how to do that today, but it does require this social political change in the short term.
So what I'm thinking then is that what might we do to buy us some time? And I was saying this earlier, that if we know that these technologies to remove CO2 from the atmosphere will be needed, and we know that they're going to take some time to achieve. It brings us to these other questions of what might you call geoengineering, that can we reflect sunlight? What ways are there of cooling the Earth? Because for me the big crisis that's looming is loss of polar ice in the next 5 to 10 to 15 years. If we can manage reflect some sunlight back out into space, maybe only 2 or 3% of incoming sunlight, then maybe we can slow down the melting of the ice caps, and maybe then we get these technologies to remove carbon dioxide from the atmosphere. But I don't see how we can do all these things quickly enough in the time frames that we've got in front of us.
I mean, I'm very concerned about solar radiation management. I mean, firstly, it's a lovely term, isn't it? Solar radiation management. It assumes we can do it and you just have to manage it. But and that's a fair challenge doing that. And there are techniques people are already talking about that we can try to apply. But then you look at them. I mean, one of the common ones that's discussed is to pump sulfates into the stratosphere, a part of the atmosphere we really don't chemically understand. We don't understand the dynamics, but we're fine. We're going to pump sulfate into the atmosphere. We'll send rockets up there periodically, and that sulfate will reflect sunlight back out into space. It will also migrate towards the poles. And then we have to keep replenishing it. Now, we could try that, but we don't understand the stratosphere well enough. That's a dangerous thing to do. So there are lots of techniques, some more or less dangerous. But another concern, of course, firstly, it may not work. Secondly, it will be used by some, and it has already been discussed in this way, as a sticking plaster over gangrene. Because you put the sticking plaster over the gangrene and you can no longer see the problem. So you can carry on doing what you're doing. But let's imagine the solar radiation management requires some sort of international protocol for us to do this. And then we get some military problem later on that breaks the international protocol. What happens then? Suddenly you'll get almost like a step change in the temperature, because underneath it your CO2 emissions have continued to rise because you've used this as an excuse for not doing it.
But I think it is right to say that we really, really must not be aiming to implement solar radiation management. It's not a desirable strategy in all sorts of ways. But when we get to a situation, we get to a situation in 10, 15, 20 years' time, when we think, oh my God, that ice cap North Pole has gone and the permafrost is melting and we're measuring methane coming out faster than we'd ever anticipated. And look, there is this technology that we could try which might refreeze the poles. At that point in time, it's this, does it make sense to do it? I don't think we should ever say no.
Some other people have been looking at this idea of if you put salt particles into the atmosphere, they act as cloud condensation nuclei. In other words, clouds form around them. So there are ways of, if you like, evaporating the seawater to produce salt, and that will produce clouds. Now, clouds aren't that well understood, actually, but sometimes clouds can reflect the sunlight back into space. They can also, of course, reflect the heat back down to Earth, but we'd have to try and understand that a little bit better. But that's another option to consider. Personally, my view on this is that we should do the research, and I've made this point a long time ago now. We should do the research on these techniques, and we should do the research on the techniques for sucking the CO2 out of the air, but all of our policy framing must assume they don't work.
Absolutely.
So they are an insurance policy that there's a very high probability of never paying out. But we should nevertheless then, so we should do the research, but assume that they won't work. And unfortunately, what we're doing is we're not doing very much research, and we're assuming that they do work.
Well, it is interesting. So the research that I've been involved with in geoengineering on the SPICE project, which stands for Stratospheric Particle Injection for Climate Engineering, a small test that we wanted to do, which didn't involve pumping anything into the stratosphere, and we had to postpone that. We had to stop doing that because of concerns about the perception of what we were doing. It wasn't concerns about what we were actually doing. It was concerns about the perception of what we were doing. And I think that this is, for me, it's a bit worrying that the perception of what we are doing in terms of pumping 35 billion tons of CO2 in the atmosphere seems not to be of any great concern. But the perception of research we might do into climate engineering is terribly worrying. And I'm not saying that it isn't terribly worrying, but I am saying that CO2 is also terribly worrying. And let's get a balance.
And all of this, and ultimately, all of it, to me, is because I take the view that we can actually make a big difference by making social changes now. We can still just about hold to 2 degrees centigrade, but it needs rapid and deep reductions by this small group of high emitters. Because we are saying we're not prepared to do that, therefore we have to think about all these other sets of issues. And I think we do need to reinvigorate that debate about actually social change in the short to medium term, whilst we put the low carbon energy supply in place. Because all of these other techniques are contentious in lots of respects, and they may not work. As if we could reduce our energy consumption today, and I say that's not everyone on the planet, that's only a relatively small number of us, then that definitely would have an impact on our carbon dioxide emissions very quickly.
I was speaking to somebody from Friends of the Earth yesterday who said, no, I really don't like geoengineering. Maybe once we've reduced our CO2 emissions down to zero, then it might be worth trying. And I kind of thought it's a bit like saying, well, once I'm cured of cancer, I don't mind trying chemotherapy. If we can get our CO2 emissions down to zero, great. Forget the geoengineering. We don't need it.
and it inspires optimism.
Well, I've got optimism.
You can come up with some ideas.
Well, I've got optimism. Firstly, I think there is optimism that because the big CO2 problem resides with a relatively small and relatively literate, a highly abusive population, when it comes to the crunch, a big change could be made. That's number one. Number two is, I think that I'm an engineer, and I think engineers, you look at the kind of things that were done in World War II and in other places. And one of my heroes is Barnes Wallis, who as an engineer turned the tide of World War II in so many ways. The bouncing bomb, the Wellington bomber. He is an inspirational figure who did these kinds of things under great stress. And we're coming into a period of great stress. And I think that our young kids at school now, in the next 10, 15 years, they'll be going through university, doing engineering, science degrees. They're going to be our new generation of inspirational people. And I'm not just relying on them rather hopefully. I just believe that the world we're going into will be very stressful and that people will rise to the challenge and great things will happen.
I think we have all the tools we need to resolve this problem pretty much at our fingertips now, but we're not prepared to use the ones that we have. And those tools are those twofold ones, as I said before. They're quite significant, very significant social change for a few in the short to medium term, and engineers doing what engineers have been very good at doing for decades and not centuries, and that is changing our infrastructure towards a very low carbon future going forward. If you put those two together, I think 2 degrees C it still remains a viable goal of our community. But beyond that, I also think there's something else that's quite hopeful, and this is something I've been thinking about more recently, is that we live in a complex world, not just a complicated world, a complex world. Climate change is a very complex problem. The great thing about complexity is it has emergent properties. Things come out that you would never anticipate. In fact, you cannot anticipate them. And the good thing about that gives every single person, all 7 billion of us, are agents for change. Most of us will fail. Most of our ideas will wither and die on the vine. But a few seeds will sort of flower and come forth. And the role of society then is to nurture those ones, to fertilise those ones, to learn from those, and then say, what do we need to convert that up, to scale that up? And if you see the world as a complex problem, you're no longer relying on the prime ministers and the leaders. You're relying on all of us as part of that change. So I think that is quite a hopeful message, that we could actually see change emerge from different places. So we need to give ourselves all some scope for thinking differently about the future.
Can I make an observation?
It's late.
It's quite cool.
Okay.
And we're both in shirt sleeves. And I see lots of people around here wearing woolly jackets and maybe if we could all learn to live in shirt sleeves when it's a bit cool, that might be helpful. It's been great talking to you.
Yes, and to you too.
Very good.
Pleasure.